Celtic Renewables was born out of a research project at Edinburgh Napier University, where we worked at basically a test tube level. From there, we have gone from the lab to this. This is no test tube. This is the first of its kind anywhere in the world, and it's a viable commercial plant, and the first, I hope, of many much larger facilities that we plan to build, both in Scotland and the UK and all over the world. If, as we must, we are to achieve net zero, then we can do this in a number of ways. We can cut the amount of carbon that we produce, we can reuse carbon, we can capture carbon, but somewhere along the line we still need to generate products that we use in our everyday lives, and these need carbon. Currently, these carbon products are produced from the oil industry. We want to make them in a different way. We want to make sustainable chemicals from biological material that has already been generated and exists above the ground, not below it. The fermentation process that I was researching at Edinburgh Napier University is a 100-year-old fermentation that went out of existence because it couldn't compete with the emerging petrochemical industry in the 1960s. My objective was to see if I could reinvent the traditional fermentation, but instead of using expensive crops as the raw material, could I use biological residues? And in Scotland, I found an abundant source of these as the residues from the fantastic whisky industry. The traditional way of making Scottish malt whisky is to use simply 3 ingredients: barley seeds, which are allowed to germinate and release some sugar, hot water, which extracts the sugar from the seeds, and then yeast, which is used to ferment that into alcohol. The alcohol is then distilled, and that's put into barrels and matures into a fine Scottish whisky. But left behind are the barley seeds that were used at the start of the process and the liquid in the fermentation broth from which you've extracted the alcohol. These are of low value to the industry, but they're still full of carbon. What we can do at Celtic Renewables is combine the solid draft material with the liquid known as pot ale and create a brand new substrate for our bacteria, who can convert the carbon in that material into high value chemicals that you use in your daily lives. At this facility, the first of its kind anywhere in the world, we're processing residues not just from the whisky industry, but also agricultural residues. And that's part of our plans for growth all over the world, is that anywhere we can find a raw material that has been generated by another industry, we can potentially process that biological material into our high-value sustainable chemicals. This could be from any food sector, any other drink sector, from the agricultural sector. The potential is enormous. We're committed to playing our part in growing a new bioeconomy, where we can replace the chemicals that we currently use from the petrochemical industry with sustainable biological chemicals. Now, in doing that, you pay a price that you will take people from the petrochemical sector. Our role is to bring those people and their skills into companies like Celtic Renewables, where if they need to be reskilled, we can do that. But they already have the talents to impact heavily on all the things that we're doing and other companies like us that have yet to come into existence. My personal view on climate change is that it has to be more about all the things we can do rather than all the things we can't. In using biotechnology to grow a new bioeconomy, we will need to innovate. And innovation means it's new. So there'll be new skills, new jobs. I don't know yet what they're going to be because they will be new. But one thing I know for sure is there will be green jobs, green skills, helping us to achieve net zero.